Good morning to everyone present over here. I am Mr. A.G. Ignatius, Assistant Professor of Department of Information Technology, Sri Muthukumaran Institute of Technology. Now, in this video, we are going to see about the subject CCS355-Neural Computer Networks and mainly second unit. So, the name of the second unit is Transport Layer. So, transport layer is the fourth layer of the OSI model and it is the core of the internet model. It responds to the service request from the session layer and it will place the request to the network layer. This layer provides transparent transfer of data between the host. Also, it provides the end-to-end control information transfer with the quality of service that is needed by the application. Now in this diagram you can see how this transport layer is working. In this diagram we have a client and the server which is connected by the internet. So client is having its own process and server is having its own process. Now this transport layer will help this client and server to send and receive the request through the processes. That is what is being depicted in this particular diagram. Now next we will see about transport layer services and functions. The various services that are provided by this transport layer are: number one is process to process communication, number two addressing, number three encapsulation and decapsulation, number four multiplexing and demultiplexing, number 5 flow control, number 6 error control, and number 7 congestion control. Now we will see in detail about these services one by one. First one is process to process communication. This transport layer is responsible for delivering the data to the appropriate application process on the host. This process involves multiplexing of data from different application processes, and together with this process it needs to know the details about the source and the destination IP addresses. So without knowing the IP address it is not possible to perform the process to process communication. So the second one is addressing. It mainly involves about the port numbers. The ports are the essential ways in which we can able to address the multiple entries in the same location. Now using this port addressing, it is possible to move from one network, move the data from one network at the same time. There are three types of port numbers which are being used: well-known ports, registered ports, and epiphermal ports. So the well-known ports range between 0 to 1023, which is mainly used by the server processes. Secondly is the registered ports, which range from 1024 to 49151, which are not at all assigned. It is kept simply registered only. Thirdly, epiphermal ports, or it is also called as dynamic ports. They are temporary port numbers which range from 49152 to 65535, and these port numbers are mainly used by the client process. Next one is encapsulation and decapsulation. Now in order to send the message from one process to another, this transport layer protocol performs the encapsulation and decapsulation of the messages. Encapsulation mainly happens at the sender side, and when the transport layer receives the data and it adds its own header to the original data. That is what is called as encapsulation. Secondly, decapsulation, which happens at the receiver side. When the message is being received at the destination, the header will be dropped and the message will be delivered to that is the destination. This is what is called as decapsulation. Next one is multiplexing and demultiplexing. So that is whenever an entity accepts the items from more than one source, this is what is called as multiplexing. That is, one receiver, many source. That is what is called as multiplexing. That is the next one is when the entity delivers an items to more than one device, which is called as the remultiplexing, the reverse process of multiplexing. One source and many destination, whereas multiplexing means many source to one destination. This transport layer performs both the multiplexing and the demultiplexing. Multiplexing happens at the source, demultiplexing happens at the destination. Next one is flow control. It is the process of managing the rate of data transmission between the two nodes. Secondly, it provides a mechanism for the receiver to control the transmission speed so that the receiving node will not get overwhelmed by the data which is being sent by the transmitting node. Now there are two broad categories of this flow control. First one is stop and wait, that is send one frame at a time. Whenever one frame is being transmitted, the others have to wait. So only when that frame is being received by the receiver, then only the second frame can be sent. That is what is called as stop and wait. Secondly, sliding window, that is sending several frames at the same time. Next one is error control. So error control in this transport layer is responsible for number one, detecting and discarding the corrupted packets. That is, if any packet is corrupted, it has to be found out and it has to be removed. Number two, keeping track of the lost and discarded packets and resending them. So once when a packet is being lost or it is being dropped, it has to be resent again. So that process is being done in this error control. Thirdly, we need to find out the duplicate packets and we need to remove it. And the fourth one is buffering out of order packets until the missing packets arrive. That is, each and every packet will be sent in a particular order. In case if any packets is being missed in between, the order of the packets will become out of order. So that particular package will be kept in a buffer, in a temporary storage, and it will wait until the missed packets be arriving. In this error control, there are two types of mechanisms involved. First one is error detection, second one is error correction. That is finding out the error, and after finding out the error, we need to correct the error. Next one is congestion control. So congestion may happen in a network when the load of packets in a network is more than the capacity of the network. That is what is called as congestion. So congestion control means the mechanisms and the techniques that are used to control the congestion and keeping it below the network capacity. There are two different mechanisms which is used for this purpose. First one is open loop, that is prevent the congestion even though it is going to happen. Number two is closed loop, that is remove the congestion after it is happened. So now next one is the transport layer protocols. Now there are three types of protocols available for this transport layer. First one is user datagram protocol, UDP. Second one is transmission control protocol, TCP, and the third one is stream control transmission protocol. So UDP is an unreliable connectionless protocol. Okay, it is a very simple one which provides this this application layer process. TCP is a reliable and connection oriented protocol that can be used in any application. So the most commonly used protocol is TCP when compared to the UDP. Third category is STP, that is stream control transmission protocol, which is mainly designed to combine the features of UDP and TCP, and mainly it is used to send and receive the multimedia items. So first we will see about this UDP in detail, that is a user datagram protocol, which is a connectionless and unreliable protocol. It will provide process to process communication to best of its service. And UDP is a very simple protocol which uses a minimum overhead. So in this protocol, we have what is called as this UDP ports. So the process, it can be either a server or the client, can be identified by using what is called as a port, which is a locator. The server will accept the message at the well-known port. Now these ports are implemented as a message queue. So whenever a message arrives in a queue, the UDP first will put it inside the end of the queue. And when the queue is full, the message will be removed one by one. That is, when the message is read, it will be removed from the queue. When the message is not read, it will stay inside the queue. This is what is called as the queue mechanism. Now this is the UDP packet format. Now this packet has a fixed header size of 8 bytes, which are made of 4 fields, each of 2 bytes. So that is a source port, destination port, length and the checksum. Each has a capacity of 2 bytes, totally 8 bytes. So we will see one by one. First is the source port number. It is the port number assigned to the source, which is 16 bits long. So this port number, is assigned to the client, and it will be, sent by the message which is being done by this particular UDP. If the source is server, then it will use a well-known port number. Second one is destination port number. That is a port number used by the destination also will be of 16 bits long. If the destination host is server, then the port number used is a well-known port number. If the destination host is a client, then it will use a temporary number which is being copied by the server on the basis of sending the packets. Now next one will be the length. Length will denotes the total length of the UDP packet. Secondly, that the total length ranges from 0 to 65,535 bytes. Next one is checksum. So UDP computes checksum over the UDP header, which has the contents like message body and also called as the pseudo header. The pseudo header consists of 3 fields, that is the protocol number, source IP address and the destination IP address. Next one is the data. It is also called as the payload. It is the actual data which has to be transmitted, and its size is variable. It depends upon the message. Now next we will see about the UDP services. First one is process to process communication. So this is used to provide the process to communication with using the socket addresses and also the IP addresses and port numbers. Next one is connectionless services. UDP provides a connectionless service. That is, there will be no establishment of connection between those 2 nodes. So each datagram will be sent by the user is independent. Third one is flow control. UDP is a very simple flow control, simple protocol in which there is no flow control at all. So hence there is no window mechanism. Next one is error control. Even though we say it as an error control, that actually there is no error control mechanism in this UDP except for this checksum. That is, the sender does not know if a message has been lost or it is being duplicated. Next one is this checksum. This checksum calculates, includes 3 sections, that is a pseudo header, UDP header and the data which is coming from the application layer. This pseudo header is a part of the header in which the user datagram is used for users to do the process of encapsulation, and some fields are filled with zeros. Next one is congestion control. So since this is a connectionless protocol, it does not provide any mechanism for this congestion control. Next one is the encapsulation and decapsulation. So when a message is being sent from one process to another process, this particular encapsulation and decapsulation process is occurring. Then the next one is queuing. This queuing methodology is associated with the ports. So at the client side, when the process is going to start, it will request a port number from the operating system. And some implementations may create both the incoming and outgoing queue, which is associated with each process. Other implementation may create only the incoming queue, which is associated with each process. Next is multiplexing and demultiplexing. So in this, the host which is running this transport protocol, there is only one UDP, okay, and but there may be several processes that may want to use this particular services of UDP. So in order to handle this situation, so whenever there are several processes which may want to use this particular UDP service. So in this particular situation, this UDP uses this multiplexing and demultiplexing. That is, multiplexing means from many source to one destination. Demultiplexing means one source to many destination. Now at last we will see about this application of UDP. So this UDP is first mainly used for processes like such as SNMP, that is Simple Network Management Protocol. Secondly, it is used for updating the route informations in this RIP, that is Routing Information Protocol. Thirdly, it is used for multicasting. So multicasting capacity is embedded in this particular UDP software itself. And next, this application is UDP is suitable for the process with the internal flow and error control mechanisms also, such as this trivial file transfer protocol. UDP is suitable for the process that requires simple request response mechanism with a little concern for this flow and error control. And at last, UDP is normally used for an interactive and real-time application that cannot tolerate even small amount of delay in receiving the message. So now in this part we have seen about what is this transport layer, what are all the various transport layer services, and we went on to what is called as the transport layer protocols. We have seen three protocols: the user datagram protocol UDP, transmission control protocol TCP, and STP, that is stream control transmission protocol. And we have seen in detail about this UDP protocol. We have seen about the various services of UDP, and at last we have concluded with the various applications of this UDP. In the next video we will see about in detail about the next protocol, that is TCP. Thank you.